Mammal Part 2 Mckenna Bell Classification. In 1997, the mammals were comprehensively revised by Malcolm C. Mckenna and Susan K. Bell, which has resulted in the Mckenna Bell classification. The authors worked together as paleontologists at the American Museum of Natural History. McKenna inherited the project from Simpson, and with Bell constructed a completely updated hierarchical system covering living and extinct taxa that reflects the historical genealogy of Mammalia. Their 1997 book Classification of Mammals Above the Species Level is a comprehensive work on the systematics, relationships, and occurrences of all mammal taxa living and extinct, down through the rank of genus, through molecular genetic data challenge several of the higher level groupings. In the following list, extinct groups are labeled with a dagger. Class Mammalia, Subclass Prototheria, Monotremes, Echidnas, and the Platypus. Subclass Theriformis, live-bearing mammals and their prehistoric relatives. Infraclass Allotheria, multituberculates. Infraclass Eutriconodonta, Infraclass Holotheria, modern live-bearing mammals and their prehistoric relatives. Superreligion Cuneotheria. Supercohort Theria, live-bearing mammals. Cohort marsupials. Magnorder Australidelphia, Australian marsupials and the Monito del Monte. Magnorder Ameridelphia, New World marsupials, now considered paraphyletic, with shoe opossums being closer to Australide delphians. Cohort Placentalia, placentals. Magnorder Xenarthia, xenatrans. Magnorder Epitheria, epithers. Superorder Leptictida. Superorder Preptotheria, Grand Order Anagalida, Lagomorphs, rodents, and elephant shrews. Grand Order Fera, Carnivorans, Pagnolines, Creodonts and relatives. Grand Order Lipotyphia, Insectivorans. Grand Order Archonta, bats, primates, colugos, and three shrews. Grand Order Ungulata, ungulates. Order Tubuli dentata, Incerta sedis, aardvark. Mirror order Eparctosiona, condylarths, whales and artiodactyls, even-toed ungulates. Mirror order Meridiungulata, South American ungulates. Mirror order Altungulata, perissodactyls, all-toed ungulates. Elephants, manatees, and hyraxes. Molecular classification of placentals. As of the early 21st century, molecular studies based on DNA analysis have been suggested new relationships among mammal families. Most of these findings have been independently validated by retrotransposon presence absent data. Classification systems based on molecular studies reveal three major groups or linear lineages of placental mammals: Afrotheria, Xenarthra, or Boreoeutheria, which diverged in the Cretaceous. The relationships between these three lineages is contentious, and all three possible hypotheses have been proposed with respect to which group is basal. These hypotheses are Atlantogenata, basal Boreotheria, Epitheria, basal Xenarthra, and Exafroplacentalia, basal Afrotheria. Boreotheria in turn contains two major lineages, Euarchontogilis, Lauraceatheria. Estimates for the divergent times between these three placental groups range from 105 to 120 million years ago, depending on the type of DNA used, such as nuclear or mitochondrial, and varying interpretations of paleogeographic data. Mammalia, Monotremata, Theria, Atlantogenata Afrotheria placentalia, Boreotheria, Euarchontigires, Euarchontaglires, Lauraceatheria, Eulipotyphia, scrotifera, chiroptera e ungulata, artiodactyla, perissodactyla, fera, folidotta, carnivora. The cladogram above is based on Tarver et al. Group 1 Superorder Afrotheria. Clade 1 Afroinsectiphilia. Order Macrocelida Elephant shrews Africa. Order Afrosoricida Tenrex and golden moles Africa. Order Tubulidentata Aardvark Africa south of the Sahara. Cloud Penungulata. Order Hyrasoidea Hyraxes or Dacis Africa Arabia. Order Proboscidea, elephants, Africa, Southeast Asia. Order Sirenia, dugong and manatees, cosmopolitan tropical. Group 2, Superorder Xenarthra. Order Pilosa, sloths and anteaters, neotropical. Order Cingulata, armadillos, and extinct relatives Americas. Group 3 Order, Magna Order, Boreotheria. Superorder, Euca Contoglires, supraprimates, Grand Order, Euarchonta, Order Scandentia, tree shrews, Southeast Asia, Order Demnoptera, flying lemurs or colugos, Southeast Asia, Order Primates, lemurs, bush babies, monkeys, apes, humans, cosmopolitan, Grand Order, Glires, Order Lagomorpha, picas, rabbits, hyeras, Eurasia, Africa, Americas, Order Rodentia, rodents, cosmopolitan. Superorder Lauraceatheria. Order Eulipotheria, shrews, hedgehogs, moles, solenodons, clade, scrotifera. Order Chiroptera, bats, cosmopolitan. Clade Ferungulata, Clade Fera. Order Folidotta, pangolins or scaly anteaters, Africa, Southeast Asia. Order Carnivora, Carnivores, cosmopolitan, including cats and dogs, Clade, Eungulata. Order Cetartiodactyla, cetaceans, whales, dolphins and porpoises, and even-toed ungulates, including pigs, cattle, deer and giraffes. Order Perissodactyla, all-toed ungulates, including horses, donkeys, zebras, tapirs, and rhinoceroses. Evolution, origin, Synapsida, clade that contains mammals and their extinct relatives, originated during the Pennsylvanian subperiod, 323 million to 300 million years ago, when they split from the reptile lineage. Ground group mammals evolved from earlier mammalia forms during the early Jurassic. The cladogram takes Mammalia to be the crown group. Mammalia formes: Morganucondontide, Docodonta, Haldanodon, Australosphenida, including Monotremata. Mammalia: Fruita fossor, Caramiavala, via. Multituberculata, Tinodon, Eutriconodonta, Gobiconodonta, Trachnotheria, including Theria. Evolution from older amniotes. The first fully terrestrial vertebrates were amniotes, like their amphibious early tetrapod predecessors. They had lungs and limbs. Amniotic eggs, however, have internal membranes that allow the developing embryo to breathe but keep water in. Hence, amniotes can lay eggs on dry land, while amphibians generally need to lay their eggs in water. The first amniotes apparently arose in the Pennsylvanian subperiod of the Carboniferous. They descended from earlier reptilomorph amphibious tetrapods, which lived on land that was already inhabited by insects and other invertebrates, as well as ferns, mosses, and other plants. Within a few million years, two important amniote lineages became distinct: the synapsids, which would later include the common ancestor of the mammals, and the sauropsids, which now include turtles, lizards, snakes, crocodilians, and dinosaurs, including birds. Synapsids have a single hole, temporal fenestra, low on each side of the skull. Primitive synapsids included the largest and fiercest animals of the early Permian, such as Dimetrodon. Non Mammalian synapsids were traditionally and incorrectly called mammal-like reptiles, or pelycosaurs. We now know they were neither reptiles nor part of reptile lineage. Therapsids, a group of synapsids evolved in the Middle Permian about 265 million years ago and became the dominant land vertebrates. They differ from basal Eupelicosaurs in several features of the skull and jaws, including larger skulls and incisors, which are equal in size in therapsids, but not for Eupelicosaurs. The therapsid lineage leading to mammals went through a series of stages, beginning with animals that were very similar to their early synapsid ancestors and ending with probainognathian cynodonts, some of which could easily be mistaken for mammals. Those stages were characterized by the gradual development of a bony secondary palate, progression towards an erect limb posture, which would increase the animal's stamina by avoiding carrier's constraint. But this process was slow and erratic. For example, all herbivorous non-mammalian-formed therapsids retained sprawling limbs. Some later forms may have had semi-erect hind limbs. Permian carnivorous therapsids had sprawling forelimbs, and some late Permian ones also had semi-sprawling hind limbs. In fact, modern monotremes still have semi-sprawling limbs. The dentary gradually became the main bone of the lower jaw, which, by the Triassic, progressed towards the fully mammalian jaw, the lower consisting only of the dentary and middle ear, which is constructed by the bones that were previously used to construct the jaws of reptiles.